Hello, everyone. Welcome. We are going to start in a couple of minutes. And while we are waiting for some people to trickle in, now would be a good time. If you guys have any questions about previous sessions or the topic, please go ahead and type them in the chat window, or we also have a Q&A window as well. I'm happy to answer those right now. So yeah, let's make use of the time. Right, first question is this session being recorded? Yes, it is. So we are recording all the sessions, and we will usually send them out after a couple of days, just so we have a chance to kind of do some basic processing and cleaning up. But yes, you will get an email. Question is, I'm not getting these emails. All right, guys, if you're not getting these emails, we send them through a mailing list. So we just use MailChimp to send out these emails. Send me an email back. Here's my email. If you're not getting any emails, contact me. Here's my email right there. So if you're not getting any session recordings, let me know, and then we will figure out what's going on. Very good. All right, guys. I guess we should get started. So today's session, we are going to look at scalable machine learning with Spark. Now, just to kind of a few housekeeping items, I want to make sure everybody is able to come to the where we are sharing the class notes. And so here's a link. It's the same link we've been using. Just put this in the Zoom window one more time. So let's kind of review what we've been looking at the last few weeks. And by the way, my name is Suji Maniyam. I'm going to be running today's session. Last few sessions were ran by Mike. Mike will come back and join us next week. My background is AI and big data. I'm a founder of Elephant Scale, and we basically teach and consult AI, big data, and cloud technologies. And all these details are, including my contact, is actually in the document that we are sharing with you guys. So let's step back and take a look at what we have covered so far. So we are at session 6 today. By the way, this link, again, just want to make sure we're all on the same page, right? So because we'll come here, right? Let me see where we are. Yeah, actually, let me just put this link right here as well, just so it's right up front. So yeah, so this is where you'll find all the sessions, all the recordings, and all that good stuff, right? So I always put the link right here. So if you're at this page, so we have session 6, what we have done. So we kind of looked at a very brief overview of TensorFlow, and we showed you guys how to actually start running these programs, and more sort of practical approach, right? How to use GPUs, how do you monitor your training is going well, how do you go to cloud, right? And the last session was about serving the model. So the previous sessions were basically focused on building the model. Session 5, we focus on, okay, you build the model, how do you serve the model, right? So we look at things like Flask and SageMaker and all that cool stuff. Today's session, I'm going to talk about how do we do this at scale. And the library I'm going to use is called Apache Spark, and I will talk about this in a bit. And the next session next week is we are going to take model serving, and we are going to show you guys how to do this at scale, right? So the last time we built a very simple Flask web service to serve the model. It's more for like testing and QA. In the next session, we are going to show you guys how to do this in a production-ready, high traffic scenario, right? Anyway, so that's this week and the next week. Always, like I said, if you guys go to these sessions, we always post the videos here. So like if you go to session 5, right, the videos are posted there as well. So check back in a few days, and you'll get an email when the video is ready, and you can look at the page. All right, guys. So that's kind of the housekeeping. So let's get back to today's sessions. So today's session is all about scalable machine learning with Spark. So I hope everybody's in this Google Doc we are sharing with you guys. So if you scroll down, you will see the little green highlight called class folder. This is where we're going to be sharing all the files. So we just go ahead and simply click on that. That should take you to a drive folder. And then here, all the assets are organized by the sessions. Right, again, one more time. Right, so again, this is the notes page we all have been using. Let me put this on Zoom. You join a little later. Okay. And if you're here, click on the green highlight class folder. Simply click and go in there, and then you will see this directory. And this is where Mike and I have been sharing files with you guys. So just look under the session. So today is 6. So if we go into session number 6, right, you'll see a bunch of files. Start with the README file. I named it as 0 README, so it shows up on the top, right? So, and then these are the slides I'm sharing with you guys. So if you guys open the README file, it kind of walks you through kind of what's covered and what I'm sharing with you guys. Okay. So the first thing maybe you want to download right now is the slides, the PDF slides for today's sessions. So you can grab those here. Don't worry about the code just yet. As we go along, I will demonstrate how the code works, and you can later download and play with this a little later. Excellent, guys. So let's get started. Let me run through the slides real quick. I'm not going to spend too much time on the slides. I want to give you guys a little context and a background, and then we're going to jump right into the labs. There you go. All right. So let's talk about this Spark thing. It's like basically Spark, Apache Spark, same thing. What is Spark? All right. So a little historical. Let me make this full screen. And guys, I have the Q&A page open, and I am also monitoring the chat window. So if you have any issues, any questions, please type them in anytime. So let's little sort of trip down the memory lane, right? Hadoop, if you heard this term, Hadoop was the very first big data platform. Came out around 2006. What is it, like 15, 14 years ago, right? And it was, a lot of people are very excited about this. And actually, as a matter of fact, this is how I sort of started my journey with big data. I learned about Hadoop, and I learned Hadoop basically on my own, and then became a Hadoop consultant. And actually, the company Elephant Scale was formed. We were doing consulting and training on Hadoop. Elephant, get it, right? That's Elephant is the logo for the Hadoop. So we call our company Elephant Scale. Anyhow, a little side story there. So Hadoop was the first open source platform that can deal with big data. So when they did Hadoop, they did 3 things. One is storage. We need a massive file system to store files. So imagine, you're using Dropbox, right? I'm just throwing files in Dropbox. I don't really care how they're storing it. They're kind of storing somewhere in the cloud. So what happens is, they're not storing all your files in like one big server. Your files are basically split and distributed across many, many machines, probably thousands of machines, right? So Hadoop basically did this massive file system. So it's called HDFS, Hadoop file system, literally, right? And that handles storage of large data. Then what they built is something called Yarn. That's like an operating system. So imagine, you're running on your laptop, you have Zoom open, you probably have Word documents, your browser open. There are multiple apps running on your laptop, and they all work pretty smoothly, right? They don't step on each other. And who's managing that? It's an operating system. That could be Windows, Mac, or Linux, what have you. Yarn was an operating system for the cluster. So imagine now, you don't have to just manage one computer. Now you have to manage many, many computers. Could be, hundreds or thousands of computers. So Yarn's job was basically running all the, keeping an eye on all the applications that are running on the cluster. So that's right. So we have a file system, we have an operating system, The next thing is basically what we call a distributed engine. So I have all this, all this data across all these machines. How do we analyze them? How do we process them? Right. So the typical way of, whether you're a Python programmer or a Java programmer, I just open write a Java program, open one file, doing the processing. That doesn't work here because my processing has to be distributed. And the first engine to do this, at least from an open source fashion, was MapReduce. Right. So as you can see, a file system, operating system, and engine. So I can write like a SQL query. For example, I say, select star from some file, something, group by something. So MapReduce Engine will take that and split my query into multiple little pieces and will run them on multiple nodes. So that was Hadoop, right? Basically, right? It's a basically distributed computing, open source, basically developed by Yahoo and open source. The open source is, so a lot of credit should go to them. And this basically launched a whole new industry for big data. Now, MapReduce was, state of the art back then, right? 2008, 2006, it was really good. But since then, we kind of started evolving our data and our usage, analytics usage. We sort of started, outpacing MapReduce. There are a few issues with MapReduce. One of them is it has a very high overhead, right? Meaning there's a lot of overhead in spinning up MapReduce programs. And it didn't support some of the modern paradigms like streaming. For example, when I say streaming, my data is not on disk yet. It's coming in as a stream in real time. Can MapReduce handle it? It couldn't. What if I want to sort of cache my data in memory and do some fast processing? MapReduce did not support that either. Right? So we're kind of outgrowing MapReduce. That's when Spark came along, right? So Spark, I sort of look at Spark as sort of a like a second generation big data platform. So if you ask somebody what is Spark, it's basically an open source distributed compute engine. That's it, right? No more, no less. And as you can see, right, it's designed to be very, very fast, like 10 times faster than the MapReduce framework, right? But even better, if you can push data into memory, it can be 100 times faster. Pretty cool, right? So it's a very modern engine. And also, in addition to MapReduce, Spark supported a lot of other compute semantics. Like, for example, you can do SQL queries. You can process streaming. And our focus today is machine learning, right? So that's basically what Spark is. And again, you guys will have the slide, and I'm going to go through this pretty quickly. I'll just zip through this pretty quickly. So again, the company that's pushing Spark is Databricks. They're basically founded by the same people who wrote Spark at UC Berkeley, right? And same people founded Databricks, and they're now commercially supporting Spark. So, and if you look at why Spark became very popular, there are a few reasons to go with it. One is very easy to use. And you will see this when you start doing the labs. In Spark, we sort of say something like develop on laptop, deploy in cluster. And I will talk about this a little later, but it's so easy to do this with Spark. And also another cool thing Spark did, they supported multiple languages. So initial version of Spark was basically Java, Scala, but then they started adding Python and R support. So, among these 4 languages, they should cover a large amount of developers. So let's say you're a Java guy, sure, right? You can come into Spark and use the Java API. Let's say you're a Python data scientist, same thing, right? Python is supported fully. So, and this is another reason Spark really took off, because just, pretty much anybody can come in and start programming on Spark. And also, like I said, it's a very high performance system, as I shown you guys earlier. And also it does a lot of out-of-the-box functionality. So you don't have, it solves a lot of the common problems we do on a day-to-day basis. So you don't have to kind of, start from scratch. Anyway, so that's kind of why Spark became very popular, and it still is. Just to kind of give you an idea, right? Kind of, version 1 was released in like 2014, about 6 years ago, right? And then version 2 was a big release that came like 2 years after 16, and this is what we use in production these days. So pretty much everybody using Spark in production is version 2. Version 3 just came out, right? I mean, this is like as bleeding as it gets, and it's also expected to be a pretty big release. Details are kind of trickling out, what they're including, but this is supposed to be version 3 is squarely aimed at being a Spark more towards AI, right? Which is good news for all of us. So, and for example, here, I'll just, I'll share this article. See, so for example, Apache 3, Spark 3 adds NVIDIA GPU support natively, right? So it's pretty cool, right? So now, and in the previous session, we shown you guys how important GPUs are for machine learning. So now Spark will support them natively. So anyway, so a lot of cool stuff coming in 3. Again, like I said, it's a very early days, and we will see what they release. Okay, all right. So we are going to be focusing on version 2.4, right, which is the production version. So a little deep dive into Spark. We look at Spark, there are different components working side by side. So for example, at the basic, we have core, Spark core. This handles the a lot of the common tasks like allocating memory, monitoring tasks, handling any failures, all those stuff, optimizing your code. All this is kind of the core. And on the top of it, then we have a bunch of modules built in. You can sort of guess, using their name. So Spark SQL, does SQL query, streaming handles streaming. This is Spark ML, right? And this is what we are going to look at today. Is does machine learning. So these are the modules built on Spark, and also the way Spark scales is it uses these guys to run and scale. For example, Yarn we talked about earlier, right? Yarn is sort of the cluster manager for Hadoop. So if you're running Spark on Hadoop, it will use Yarn to scale. It can be Mesos, and now latest is more Kubernetes. Like a lot of people actually are doing Kubernetes to deploy Spark. And also, when Spark is running, it needs a distributed file system. And as you can see, it can work with cloud file system, whether it's Amazon, Azure, Google, or if you're running in-house file system, HDFS, it'll work just fine as well. Even databases like Cassandra, MySQL. So Spark can read and write data from a lot of different file systems. Right? Could be cloud file system, in-house file system, or even like databases. So as you can see, this is kind of the high-level structure of Spark. And guys, any questions, please put them in, and I will answer them as we go along. All right. So I'll kind of skip some of these because we talked about them. Like I said, you guys have the slides. I don't want to just spend too much time in the slides. So some of the use cases, you can sort of see here, right? Right. So you can see, these guys use cell phone signal analytics. So you can see they analyze huge amounts of data, and their stack is Spark and Hadoop. This is Yahoo. This is kind of a pretty cool use case. So for example, they were using like for Yahoo News, they were initially had like 15,000 lines of C++ code, and now, right now, just 120 lines of Scala, Scala code in Spark. Anyway, so you can sort of see here how productive Spark is. Okay, Netflix is in the extreme use case, right? You can see they process massive amount of data, and their stack is basically Spark and Cassandra. So you can see, right, Spark is pretty much used anytime we need massive scale. Okay. All right, guys, so I'll kind of skip over some of these. So again, kind of, just want to, show Spark and Hadoop. This is something I thought is funny. I don't know if you can see, saw the ad. I'm a PC, I'm a Mac. This is like a video that came out almost 5-10 years ago when the new MacBook started coming out. So kind of, so we make fun of it like this right now. Like Spark is sort of the PC, right? It still works, but little, not very, right? Not all that exciting. Spark is sort of the, the new MacBook, right? Shiny and yeah. So anyway, so that's that. So, anywho, but however, Spark actually works along with Hadoop. So the way Spark works with Hadoop is you can see the Hadoop stack here. You have multiple nodes, you have file system, operating system, and Spark is the engine, right? So if you're deploying Spark in-house, this is how it'll look like, right? Working on top of Hadoop. And again, don't worry about this, like for example, if you're wondering what is Hive, Hive is like a data warehouse for Hadoop, where you can define tables and schemas and things like that, right? And Spark can work with these as well. Anyway, so Spark plays nice with Hadoop. So how do you run Spark? There are a couple of options. So if you're running Hadoop Spark on-premise, right? If you're building on your data center, usually you would end up running it as part of your Hadoop cluster. So if you have a Hadoop cluster, most likely you'll also deploy Spark along with it, right? Or there are a couple of hosted options as well. If you're running the cloud, Databricks has their own offering. Remember, Databricks is the company that's pushing Spark, right? So they release Spark as open source, but they also built a cloud product where they offer a hosted version, which is pretty nice actually. I'll show you guys how it looks like. And also pretty much all the cloud vendors, they also support Spark. So the two options, right? On-prem, on the cloud, right? So just very quickly, Databricks, right? Remember Databricks, their hosted version is called Databricks Cloud. And basically, you can actually get a free account on their community edition, right? So I think they give you, what do they give you? Okay, yeah, they give you like just a single machine. So, you cannot do like multi-node clusters with memory capped at 6 gig. All right, not bad, right? Just sign up and then, you can start using, there's nothing to install, which is pretty cool. And also you can sort of see here, this is a usual sort of a Gartner quadrant, right? You can sort of see here Databricks is on the sort of the top right, right? And this is a desired place to be, right? Meaning, right, whenever they do technology evaluation, and this is a very, very, very popular Magic Quadrant, right, method, you kind of want to be in this quadrant. And, and you can see Databricks is doing pretty well there. Anyway, right, so because kind of getting started with Spark, basically go to the Databricks cloud, sign up, and you can start playing with it without having to install much on your laptop. Yeah. Somebody told me they lost sound. Can you guys still hear me okay? If you could, just please confirm on the chat window if you can hear me. All right. So yeah, if you have sound issues, what I recommend is just restart Zoom. Let me just type this in so the other person knows, because they can hear me, obviously. Sound issues, please restart Zoom. All right. All right, guys. So that's Databricks Cloud, right? And that's done by the company Databricks who's developing Spark. But also, if you're on other cloud platform, let's say you're on Google, you're on Amazon, right? You're on Azure, all the cloud vendors, they have basically these days like a very good support for Spark. So the idea goes like this. You basically upload your data into the cloud storage, right? By the way, everyone has their own, right? Amazon has S3, Google has Google buckets, whatever, right? And then what you do is you basically spin up Spark on an on-demand basis. So like you're running a query, you want to run, quickly analyze your data, you spin up Spark, and then you shut it down. Your cluster shut down when you're done. So you don't even need to keep the cluster running for how do you say 24/7. Like if you're doing an on-prem cluster, you will be running 24/7, right? And it's running all the time, whether you are using it or not. It runs all the time. But in cloud, just like every other cloud service, you just pay for what you use. That's it. Okay. Let me 1 second. Let me quickly do one thing real quick. I want to make sure my cluster is not dead. Let me get this going, guys. Because I actually have a Google Cloud cluster spun up. What it will do is it will basically shut down after a while if no apps are running. So I don't want to kind of die on me just in the middle of the class. So, all right, okay, I'll keep it busy. All right, so some questions are coming in. That's very good. I'll answer them. So here's the basic premise. Everyone has a different name. Amazon calls them Elastic MapReduce. Don't let the name fool you guys. I mean, they were one of the first people to do Hadoop on demand, right? Because Amazon was in the cloud market first. So they still call it Elastic MapReduce, call EMR. But these days, very few people use MapReduce anymore. We use Spark, right? But the product name is still EMR. So when you do, and what does it give you? It gives you an on-demand Spark cluster, right? That's pretty much it. All of these people are going to give you an on-demand cluster. Google calls your product Dataproc, right? And this is what I'm going to demo to you guys. And as you have something called HT inside, right? So everyone has a different name, but basic idea is on-demand Spark clusters, right? All right, so a few questions coming in. Let me pause here for a second and take some questions here. So the question is, how long does it take to start up Databricks versus EMR? Yeah, good question. So like, for example, how long does it take to spin one up? I'm going to demo this to you guys in the next few minutes. basic, like for example, Dataproc, probably a minute, right? A minute or two, depending on how many machines you are requesting. So it's not seconds, but usually like, anywhere from 30 seconds to 2-3 minutes. Because remember, when you are doing spinning up, they have to actually go and, provision machines, install all the software, do the whole thing, right? Yeah. So it's not instant. Be prepared to wait like, anywhere from 30 seconds to 2-3 minutes. The Databricks Cloud is they do a little smarter. What they do is they already have these instances, up and running, right? And they can quickly allocate these to you very quickly. So the way they do that is like they can keep these instances running, right? And as the demand increases, they will start spinning up more machines. So when somebody says, hey, I need a cluster, they can quickly assign a machine for you because they don't have to spin up a machine, right? Because they already kind of have one running, right? Yeah. So Databricks does a little better, but more or less, you can mimic the same behavior with these guys as well, right? Yeah. So that's question, right? Very good. That's a great question. So yeah, so it depends on how much cluster, like, if I'm spinning up 3 machines, maybe it'll take a minute. But if I'm spinning up, say, 300 machines, maybe that'll take like 5-6 minutes, right? Because they're gonna go and spin up all the machines and do all that. So yeah, good question. Another question is, right, so is there a free access in HT Insights? I believe so. Good question here. Oops, sorry. Give me 1 second. I think I closed the window by accident. So yes, there's an HT. So if you go to HT Azure HT Insights, right, you'll see this. Say Azure Spark, right? Yeah, HT Insight is what you want. So yeah, so they do have a free account, and I think it gives like a 1 year worth of something. Anyway, you can look this up, but yeah, they do give you, and you can sort of see here, right? They support Spark, Hadoop, Kafka, right? Or all the stack is included, right? So that's pretty neat. Yeah, so it's a good way to get started. You think you're up to like 12 months. Yeah, there you go, right? 12 months or $200 worth of credit or something like that. Yeah, so that's neat. So good, guys. Let me see a couple more questions. So question is, what is PySpark, right? So PySpark is basically Spark with Python, right? So if somebody tells you I'm using PySpark, what they're telling you is basically they're using Spark, but they're using Python to program. That's it, right? Yeah. So it's not like a separate thing. It is just Spark. I'm programming Spark using Python. By the way, remember Spark supports many languages. Spark and Python is sort of the most popular combination. So that's why you hear people saying PySpark. Same thing, right? Yeah. Good, guys. All right, what else? Question is, should I have Hadoop or Spark? Good question. So let me go back here. There you go. This is what I show you guys, right? So remember, when Hadoop started, right? Hadoop's built-in engine was MapReduce. Sorry, there's a typo here, not reduce with a C, right? Reduce. And like I said, 10 years ago, it was great. It was state of the art, but it's no longer. So I don't know of any of our clients that still use MapReduce. There's like one client we have, they have a lot of legacy applications on MapReduce. They're gonna keep them running. But all the new application development is basically doing Spark. So I'd be very surprised to hear if anybody is still actively developing on MapReduce. It's very unlikely, right? So MapReduce is pretty much out of the picture. The new engine is Spark. And the way Hadoop does is like, for Hadoop, it doesn't discriminate. Like today, Spark supports. Let's say tomorrow there's a new shiny engine comes along, and then Hadoop will support that too, right? So think of Hadoop more like a platform, because when you say I should use Hadoop or Spark, what you mean is should I use MapReduce or Spark? And there the answer is pretty simple: Spark always, right? Hands down. But remember, Hadoop also gives you a lot more than Spark, right? Spark is just one component. It's basically an engine running on top of the Hadoop platform, because Hadoop gives you a file system, operating system, data warehouse, all that. You need all that to do any meaningful analytics. So hopefully that makes sense, right? Yeah. So Spark as an engine, Hadoop as a platform. Again, if you're running this, in-house, right? Yeah. If you're running in cloud, you don't need to, set up Hadoop at all, right? Because the cloud vendors will do this for you. Next question is, does it matter which cluster manager we use? That's a great question. So let me step back real quick here. Remember this diagram? There we go, right? Because Spark works with multiple cluster managers, because the way Spark is structured is it depends on these cluster managers to run its program in parallel. Now, which one should we choose? Honestly, the cluster manager choice is going to be determined by your ecosystem. For example, if you're running Yarn, if you're running Hadoop, you're pretty much going to be using Yarn, right? And if you're on the cloud, you probably end up using Kubernetes, right? So based on what you guys have existing, and Spark works well. Question is whether it's one faster than the other. It's kind of hard to say, because all these managers, they kind of have little tricks to make sure the provision time is very quick, right? So you're not waiting like 5 minutes to spin up your job, right? We're talking like anywhere from 30 seconds to a minute at most, right? The deployment is very quick. Let me see. Okay, yeah. So app is running. Okay, that's good. All right, guys. So hope that's really good. Yeah. Great questions. Love those. Keep them coming, right? I can hear myself in my eyes. Call, please. I'm on a conference call. Okay. 1 second, guys. Oh yeah, that was my that was my kid running inside. Yeah, as we know, we all working from home, right? So, all right, guys. So very good. Any other questions on this one? Very good. Yeah. So, right. So we have a pretty decent understanding of what Spark is, so and how to run Spark, right? So basically, 2 ways of running Spark: on-prem deployments on top of Hadoop, or there are cloud solutions, either Databricks or any cloud vendor, right? So very good. Let me see. Yeah. Again, so if you're doing on-prem deployments, we recommend you guys do. This is some of the hardware requirement. You can sort of see here, right? These things you need like a lot of horsepower, like and a lot of memory, and that's typically Spark, right? So Spark is kind of resource intensive, but you get a lot out of it. So how does Spark scale, right? So let me kind of talk about this real quick. So imagine this: when you're running Spark on Hadoop. So the way I'm breaking this into is like Spark works differently on both options, whether you're running on-premise on Hadoop or in the cloud. 2 different approaches. Let me explain them both. So the way Hadoop does, so Hadoop here's the left-hand side on Hadoop, right? So Hadoop, I'm sure is showing multiple nodes, right? These are called worker nodes. And you can see my data is actually distributed across many machines. And also my processing also running on multiple machines. So the Hadoop architecture was basically the processor who was doing the processing or computing usually computes the data on the local machine, right? So if I'm a processor, I'm going to be processing basically data that's locally on my machine. Same thing, right? So pretty much the machines are independent, more or less, right? So this is why Hadoop was able to scale to massive scale. Like we are seeing clusters, people running Hadoop on like 3,000, 5,000 machines, right? Truly massive scale. And Yahoo, who basically created Hadoop, I think they had the largest cluster, I think like 5,000 machines, right? How are they able to do this? Because by localizing data, this is called data locality, right? So what it means is your processing focuses on data that you already have on your machine. So I'm not streaming data right across the network because that'll be slow. So I'm focusing on data that's stored locally. And this is called data locality. So if you're running Hadoop on-prem, this is what will happen. Let's say I'm running Spark here. You can sort of see here Spark running. So you can sort of see here Spark. I'm showing 2 machines here, data node 1, 2. And you can see the Spark process is basically consuming the local files on both machines, right? So this is what Hadoop did, and this has been very effective. So if you have basically on-premise architecture, this works really, really well. And also, but the downside is when you build a cluster, the size is fixed. So for example, let's say you built a 10-node Hadoop cluster. It's pretty much 10 nodes, that's it, right? You cannot go to 15 nodes on a whim. The cluster size is pretty much fixed, right? Because that's how Hadoop is structured. So the cluster size typically is, what have you set up as? So it's not very easy to kind of go from 10 to 15 or 20 quickly. It takes a lot of work, a lot of effort to expand your Hadoop cluster. So that's a downside. So does it make sense, guys? Like when you're running Spark on Prem, on Hadoop, the way it works is like, right, Spark runs, Spark consumes mostly local data. What when I mean local data, the data that's stored on that node. And as you can see, as you stack up machines, they can grow horizontally. Yeah. All right. Now in the cloud is a different story. So in the cloud, what they've done is like so by the way, in the previous diagram, we co-locate data and compute, meaning data and compute running on the same machine. Now in the cloud vendors, what they do is now data and storage and compute are separated. So here's a cloud storage, right? It's like some, Amazon S3 or Google Cloud, some bucket. And the computation is done outside the storage. And you'll say, wait a second, how is this going to even scale, right? Because at this point, what are you doing? You're basically streaming data from storage. Each machine will be streaming data from storage into them over the network. That is true, right? So my compute nodes, or let's say Spark or some other program, they are streaming data from a bucket, storage buckets. For this to work, we need an incredibly fast network. And this is what cloud vendors have built, right? So one of the examples I can show you is sort of Google, right? Built this network, using their own technology. Like they basically built everything, hardware, software, they even designed their own network switches, right? It basically gives them access, the bandwidth, this insane amount of bandwidth, right? So this is called petabit network, right? Right? We are still, in like gigabit networks, right? Like when you build our data centers, we are in gigabits, right? 1 gig, 10 gig networks, but multiply by 1,000, right? Petabit. So just to kind of give you an idea how how effective this network is, basically you have 100,000 machines. They can basically exchange information or exchange data at 10 gigabits a second, right? That's the kind of network we are talking about. So if you want to pull this off, if you want to separate storage and compute, you need a really ultra fast network like this, right? So very different architecture. But the reason it works is like, this is what cloud vendors do, right? They invest a lot of money in the infrastructure, the networking and all this, and it works for them. So a very important distinction, right? So this is on the cloud, storage and compute are separate. Why is that, right? Why was this architecture chosen for cloud? Because it gives a lot of flexibility. Because what they can do is like now they can quickly spin up machines without having to do anything with the storage. So the storage is already hugely scalable. So let's say I'm spinning up a Spark cluster. So for one query, I need 5 machines. Let's say I'm running another query that needs 20 machines. No problem, right? We just spin up as many machines as we need without having to touch storage. All my data is safely in the storage. I just spun up machines, compute nodes, as many as I want. And it doesn't matter because why, right? Because you can see, right? You can see the benchmarks, right? Even if you spin up 100,000 machines, they could be reading at 10 gig per second, right? Trust me, none of us are going to spin up 100,000 Spark machines, right? But that's the kind of scale we are talking about. And this needs a really massive infrastructure only the cloud people can afford. It's very hard to do this on-prem, right? So, right, because in the on-prem architecture tends to be like this. Hadoop-based things, fixed size clusters with data and processing co-located. Cloud architecture, again, this is not something we designed, it's already been done for us. is two separate right systems, storage and compute. And again, if you're going to use this, you probably need to be in a cloud environment, right? This is not something we can do in-house, at least not easily. If you're in a cloud, basically, you're kind of paying for use, right? So because if you're building an in-house cluster, you already pretty much paid for it, right? But with the cloud, every time you spin up a machine, you're gonna pay for it. So that's a kind of a trade-off, right? But this is I can tell you, I mean, from working with us, in this, for a number of years, this is a very, very flexible model, right? If money is no object, this is the way to go, right? So because you don't have to worry about managing machines, like scale. Like today you need 10 machines, tomorrow you need 1,000 machines, no problem, right? Just spin up machines as many as you want. All right, does this make sense? Kind of, right? Again, I'm giving you like a little high-level overview as well, how Spark is running. Any questions on this one, guys? Please go ahead and type them in. All right. Happy to answer any questions. Okay, so now that we understand how Spark scales, like on-prem and on the cloud, let's talk about how it actually works. So here you can see I'm spinning up a Spark application. I'm submitting a Spark job, it's typically called. What's the first thing it does? It has to go and talk to the cluster manager to ask for resources. To say, okay, Mr. Cluster Manager, I need 10 machines with, I need 4 gig memory and 2 CPUs and all that, right? You give the spec, whatever the machine you're looking for. So the cluster manager is in charge of distributing the machines, right, evenly across, across applications. So cluster manager will look at the cluster, depending on how busy and how utilized the cluster is, it'll give you the resources. So let's say you ask for 10 machines, maybe, cluster manager might give you 6 machines, right? Because, cluster may be busy, right? If the cluster is idle, sure, you ask for 10, you got 10, right? Anyway, so a bit of a negotiation going on. And then once the cluster manager assigns you the machines, then you simply deploy your code into the machines and run them. So when I say executor, right, this is like your execution engine, right? So, as you can see, I have 2 executors. They're running parallel. And even within the executor, they can spin up many tasks to even more parallelize your data, your processing. So Spark is very smart about this. Not only they will run on many, many machines in parallel, like, so, this guy and this guy are running parallel, but even within the executor, they will spin up many tasks to even subdivide their, subdivide the work. So, and yeah, so that's why Spark is really good at this. So they will try to parallelize as much as possible. Right, so that's kind of the submission, like submit a program, go to cluster manager, negotiate, get the resources, deploy our code, and start running. That's it. Right. So, all right, so I'll do the lab a little later. So that is basically a quick introduction to Spark. Now let me talk to you guys very quickly about machine learning with Spark, right? Because this is the focus of the series, but I kind of want to give you guys a quick overview of Spark in case you're new to it. So now you're getting into the SparkML, right? So again, we know this by now, right? It's SparkML. So this is, sorry, there's a typo here. This is SparkML, right? This is a component we're going to look at. But as you can see, Spark has a lot of other components like streaming, SQL, and all that, graph processing, all this. But we are going to focus on SparkML. All right, machine learning at scale. So if you've been doing machine learning, even pretty much a lot of the demos we have shown you guys, they were running on a single machine, right? Even when you're using Jupyter, what's happening? Jupyter is running on a single machine. So if you have a small amount of data, that's fine. You had a few gigs of data, you can analyze. May take you a few minutes, and that's how it was. But as your volume is growing, let's say I'm getting I'm going from gigabytes to terabytes of data. We need to scale our processing too. What do? Right, so we go from single machine to a cluster. Now this is not an easy path, right? Because like a lot of the applications, they only work on single machine mode. Like for example, if you're using say scikit on Python, it's designed on a single machine. You can parallelize a little bit by running on multiple CPUs and all that, right? But it probably not going to work on multiple machines. So we need a completely different architecture to go from single machine to a cluster, right? So that's the rationale behind this. So let's say I'm a data scientist. Let's say I'm working on my Jupyter notebook on my laptop. Right, this is how most people start, right? We can experiment, build some models, run it, and see how it goes. And then I say, okay, right, this is looking good. It's time to go to the cluster. So what do we do, right? So this going from a laptop to the cluster is not always straightforward. And in the previous sessions, Mike also kind of alluded to this, right? So this is called deployment gap, meaning I have something working on my laptop. How do I deploy this on my cluster? Not easy usually, right? You have to kind of talk to a data engineer, do some coordination, a lot of work involved. With Spark, going from laptop to the cluster is very easy. And I'll show you guys this, when we do our demo. So remember, in Spark, we say develop on laptop, deploy in cluster, right? Spark is designed for this kind of work, right? And if you're a data scientist, you're going to be spending a lot of your time on running on your laptop, building a small model on small scale data. And then when you feel comfortable this is ready, then we go to the cluster, right? And this is a problem, and a lot of the cloud vendors are trying to solve this too, right? Because they also understand, okay, how do you go from a single machine to a cluster, right? So, and I'll show you guys how Spark does it. So remember Hadoop? Hadoop was the first, distributed platform. So a lot of people try to kind of say, okay, let's do machine learning using Hadoop. And when Hadoop came out, this engine was MapReduce. MapReduce was not really good at machine learning because MapReduce was kind of clunky, kind of had a lot of overhead. This effort really didn't take off. When Spark was being designed, one of the design goals they said is like they want Spark. The designers wanted Spark to be a scalable machine learning framework, right? So a lot of the design decision went into Spark, kind of based on this. For example, the engine is much lighter, right? So it's not a heavyweight like MapReduce. It can do, it can process data very, very quickly. And what it means is like translate. It's really good at iterative tasks. So now, if now your machine learning brain should kick in and say, aha, yes, we need iteration. Why? Because a lot of the machine learning algorithms iterate over the data many, many times, right? Pretty much all data, even simple like a linear regression, will go over the data many times until it can converge. So we need whatever framework we are using has to be really good at iterative, and Spark is, right? Spark is really good at it. And another cool thing Spark did was they actually ship with the ML library. And it basically has a lot of the popular algorithms you can think of. Your regressions, your classifiers, right? Your clustering algorithms, they're all built in. So we don't have to start from scratch. We can just use them, right? And not only that, the Spark implementations are parallelized. What do I mean by that? Remember the diagram before, right? The whole point is we are going to the cluster is I want my compute to run on many, many machines. So let's say I'm running a regression algorithm. Here, like a scikit version will just run on only a single machine. Spark version will run on multiple machines, right? Because that's the only way to scale. So yeah, all the algorithms Spark has are parallelized, which is very cool, right? Another cool thing Spark does is it's called memory caching. So what do I mean by that is, let's say you have some medium data, like not too big, maybe like a few hundred gigs of data. What you can do is you can actually load the entire data into memory. So, and if you that's assuming if you have enough memory, and memory is cheap these days, right? I mean, people say memory is the new disk, right? Because the memory prices have really, really come down quite a bit. I was just, trying to buy some machines for a client. Remember this, So we show them, oh yeah, minimum 256 gig memory, right? But the machines they were getting, they have 512 gig memory. They don't even have, the vendor doesn't even have anything below 512 gig because the memory is so cheap, right? They don't, like even the sort of the moderate machine you're getting, has like 512 gig memory. And so imagine you have 10 machines with 512 gig each. You have like 5 terabyte of memory pool, right? Which is not bad at all, right? So 5 terabyte of memory, you can do some pretty serious computation, right? So that's why I said when Spark can actually cache data. Now imagine the example I just mentioned. You have 5 terabyte of memory to cache. So if your data is only like you say 300, 400 gig, Very easy, right? Cache it, load it in memory, and then do it basically in-memory compute. Super fast. Right? And also don't forget multiple language support, right? So pretty much, these 4 languages cover pretty wide spectrum of developers. For machine learning, Spark and Python is a very popular combination, right? Because we love Python, very easy language, and a lot of machine learning people, they already kind of know Python, right? They probably use scikit, SciPy, all this stuff, right? So when they come to Spark, if they can use Python, right, even better, right? So Spark and Python has become pretty good combination for machine learning. All right. So that's how machine learning and Spark has really become a de facto platform for machine learning. Yeah. So just to kind of give you a sense, how does Spark parallelize computation? Right, I'm going to go through a very simple example. So imagine I have some data. Let's say assume my data is distributed across many machines. Like, so when I say P is like a partition. So my data is partitioned, meaning divided, and I have 3 partitions of the data across 3 machines. So let's say I want to do a count. So let's say like think like a, in SQL, do like a select count star, right? I want to count how much data I have. So how am I going to parallelize this, right? You guys can figure this out pretty quickly. You can say, oh, you know what? This worker is going to count whatever I have in this partition 1. This worker on partition 2, so on and so forth, right? So everybody does count, local count. So let's say this guy says, okay, I have 5, I have 10, right? So like this, I have 5 records, I have 10 records, right? I have 7 records, and they all send their records to an aggregator, and the aggregator can add them up and give you the final result. So let's come and say, okay, yeah, we have totally 22 records, but the count was parallelized, right? So everybody's kind of counting what they have. And this is a very popular pattern, right? And this is kind of what Spark does. And you can sort of generalize and say, okay, how do I find, say, max, right? Things like that. Same principle, right? So Spark is very good at figuring out, okay, what's my operation? How do I divide the work and do it in parallel? And of course, this is count, sort of the simplest thing there is, right? But machine learning algorithms tend to be more involved. But but Spark ML library will parallelize the work for us. Yeah, makes sense? Okay. All right, guys. So Spark ML library is kind of going through evolution as well. The very first implementation is called ML Lib. And the new one is simply called SparkML. And this can be a little confusing to people. The history is the first version ML Lib, it was built on an older data set called RDDs, right? It's not a very high performance data set. But the new ones use a new data set called data frames. Right? Just coming from R or Python, you know data frames, right? Similar idea in Spark, but these are much faster than the older ones. So anyway, so long story short, Spark ML is what we should be using, right? It's faster, better, and this is the one being, getting all the new features. The old library is still around for compatible reason. It may go away, in the future releases. Anyway, so if you're looking for code and whatnot, right? And the name is unfortunately a little confusion, and I wish they probably did like Spark ML Lib 2 or something, right? Just to make it clearer. But the names are like ML Lib is old, ML is new, right? Just something we have to remember. So if you're looking for algorithms, make sure they are based on the ML, the new library, not the old one. So, all right, and here are the algorithms Spark has implemented. And this is like a kind of snapshot. It doesn't cover all of them, but it shows the popular ones. Think of it like a little flow chart, right? So for example, these green ones are kind of the type of algorithm you want. Like for example, I want classification. And what are the algorithms? It has a naive Bayes. Like if you have text data, you have naive Bayes, right? SVM, low-stage regression. These are all popular algorithms that all the machine learning people learn. Let's say I want to do like a regression. Here's your random forest. Right? Boost a tree. If you want a clustering, here's a k-means, right? So all of these, the ones on the red, those are the implement algorithms, and you can see they're all pretty popular algorithms. So let's say you want to use k-means. You don't have to go and write k-means in Spark. Spark already has a library that does it for you, right? So anyway, so Spark covers all the popular ones, and people are all, there's like an open source repo. People are checking in their work, so let's say there's an algorithm that's not included, you may want to check this open source repo that's called Spark packages, and somebody may have checked in a library that does that. So what we're going to do, right? So that's kind of the sort of the theory part of this. What I want to do is I want to show you guys how to run an algorithm. I'm going to use k-means because that's a very simple algorithm to run and understand. And I'm going to show you guys how to run an algorithm locally on my laptop, and also how to run in the cloud. Right. So let's pause here for a second, and then see if you have any questions. Sort of SparkML. I'll sort of set up like a 1-minute timer, right? So this way we can actually field some questions. Please type it in the Q&A window or chat window. I'm monitoring both. So let's take a quick break here to questions. My question is, how is the version 3? Version 3 is just came out. I think they did the preview release last I checked. Yeah, there we go, right? So version 3 is still in preview. So as in like it's not GA yet. So I haven't really looked too much into version 3 yet, but basically it's a release that's geared towards machine learning, right? So anyway, so yeah, so I'll check it out again. It's a preview release, so you can download and play with this. There are some articles out to come out that talk about what's in version 3. Yeah, worthwhile, right? So, all right, guys. So let's look at k-means. So what is k-means? K-means is a clustering algorithm. Let me see. There we go. Right. So let me show you this. Again, just a very quick about clustering. So what the clustering does, it looks at bunch of variables and tries to find groupings. So imagine I show I did like a plot, sort of 2-dimensional plot, x and y axis, and this is what my plot looks like. I mean, for now, ignore the color coding. And if I ask you, do you see any patterns here? You'll see, sure, I kind of see 3 distinct groups, right? And maybe, and this is an example I'm showing, maybe these distinct groups are like, let's say I'm clustering beverages. So, since all the white wines, since they share most of the qualities together, they tend to sort of cluster together, right? Red wine, it's a little different, right? Different tasting and different properties. They tend to cluster, separately. And beer, is different from, these guys. So it tends to cluster this way, right? So this is basically clustering. Clustering is finding patterns. And this is used pretty widely, like for example, right? So things like, think about anomaly detection. For example, let's say I'm analyzing some traffic, or like some sales or some credit card transactions, right? Let's say most of the typical ones, let's say they fall under this, this kind of area. And if I see something outside my common one, then I can flag the transaction. Or maybe somebody's trying to hack into my data center. Maybe somebody's trying to do credit card fraud. So how are we doing this? Because by basically grouping and then finding patterns. Right? So this is basically called clustering. Clustering meaning we're trying to find similar clusters. Yeah. So anomaly detection is a very good example. Google News does clustering very well. Like for example, if you just read Google News, if you go and sort of go to let me just show a demo real quick. Right. news.google.com, I think. Yeah. Right. You know how you read the news, right? There's a heading, right? And then they will say something called view full coverage, right? What does it mean is, so they're clustering, right? So they're reading all the news stories and they're realizing, okay, they all talk about the same topic and they're kind of clustering, right? So for example, let me see, what is it? There you go, right? So here's a, some polling about, say, Biden versus Trump. So here's a headline, but if you click on the full coverage, you will see many articles about the same topic, right? From like, here's one USA Today, The Hill, right? Washington Post. Right? Anyway, so the idea is they cluster the coverage, meaning similar items are clustered together, Right? So Google is a great example. So the way the clustering, this is what we are going to do in this demo, and it's a pretty fun lab, is clustering, figuring out Uber demand, right? Where do we get most demand from, right? In clustering, right? We are trying to cluster our Uber requests to identify where is most of our traffic requests coming from, right? So I'll show you guys how this is done. Anyway, so a lot of real world use cases in clustering, right? So that's that. So the one I'm going to look at is called k-means. It's very simple. It's kind of, let me demonstrate to you guys this one here. So let me, right? And again, this link is in the, I'll put this link in your document here, just so I don't forget it. Part 3 k-means demo, right? From Stanford. All right. So okay, here's my data. Imagine I have like X and Y axis, right? But in real world, we will have more than 2 axes. But let's say this is my data. So you can clearly say, you can clearly see in 3 groups. So in k-means, I'm going to say, okay, go find me this group. So what k-means will do is like they will sort of start at some random position. These triangles are random, right? The idea is, because I don't know where the groups are, right? Because even though visually we sort of see, imagine for a computer, it doesn't know it yet. So it's going to start at a random position. So these triangles are the random positions. And the idea is, each time I go through the data, this triangle should move and find these centers, right? So can I watch the triangles when I click the next button, okay? So I'm clicking next. Can I watch the triangles carefully? See how they are moving, right? So every iteration I'm doing, so I'm clicking on the mouse, right? You can see this, right? See how the triangles are kind of, migrating and kind of, trying to find these clusters. That's exactly what's happening. Pretty cool, right? So let me do it again. Let me refresh, right? So again, different data. I'm saying go find me 4 familiar clusters. So we put 3 things randomly, right? So right now, they look at this triangle. They're like just placed randomly. So every time I click, what I'm doing is I'm iterating over the data, right? I'm looking at the data and trying to sort of find the best grouping. So first click, second click, see like pretty immediately, right? The triangles kind of migrated towards here. So as you can see, the more times I click, my clustering gets kind of fine-tuned. So this is basically what k-means does. It'll try to find similar patterns. Pretty cool, right? So this is a nice demo. But if you're wondering, okay, so that's neat, but what's the use case? Use cases are like this. Remember we talked about things like predicting Uber pickups, trying to do things like anomaly detection, right? So things like this, yeah, are pretty useful. All right. So this is what we are going to do, guys. So here is your code. Let me show you guys here. Okay, so if you're in your README file again, kind of I'm going to walk you guys through this. All right. So here's the top level directory we are sharing with you. So come here. All right. Let me put this link in Zoom again because we'll join a little later. So here's the top level files. Come down and click on the class folder, the green highlight. Right. Come into that. Okay. And these are organized by sessions. So today we are doing session number 6. All right. And then from here, just look at the README file. Right. So that's what I'm looking at here. And the README file has links. I just put some links for you guys, things like k-means and the Spark 3 announcement and all that. And also it has instructions on how to run the code. So if you're in the directory, you'll see a bunch of files. So I'm going to show you guys how to do this on a single machine, right? So here I have Jupyter running on my machine, a Jupyter notebook. Again, the instructions are there, guys, right? So don't worry, just kind of watch my demo. So let me do this, right? So here's my k-means, just a typical Jupyter notebook. And what I'm going to do is I'm going to analyze Uber data, pickup data. And I got this data from a Kaggle competition. This is a very popular competition a few years back. It's basically all the Uber data, Uber pickup requests in New York City. And I look at the data, it's pretty straightforward. If you look at the data, let me zoom in a little bit so you guys can see better, right? Just timestamp, right? Timestamp here. And then basically latitude and longitude, that's it. These are GPS coordinates. of where the pickup was requested from. That's it. And then well, base numbers, I think they're segmentation, but we don't care about that. So all I care right now is the location, lat and long. Right? So what I'm going to do, right? So here, remember, I'm actually using Spark here, right? So this is not a Python scikit notebook or TensorFlow notebook. I'm going to use Spark. So the first thing what I'm doing is I'm initializing Spark. Actually, let me restart the kernel just so I have. Yep. All right, start kernel. Like I said, it's going to initialize Spark, right? And I'm just going to read the data, right? I'm just going to read a very simple file, just has only 10,000 samples. Okay, so going through that. And also I'm defining the schema. I'm defining the schema. I'm saying latitude, treat latitude as a floating point, treat longitude as floating point, because these are the two things I really care, right? I don't care about the time just yet, right? And I'm saying read the file. Okay. So again, as you can see, right, I'm not using TensorFlow read or anything. I'm using Spark to read the file in. So I'm saying Spark read, Spark read CSV, and I'm saying yes, there's a header, meaning like the first line is a header, and then use my schema. What is my schema? My schema is instructing Spark to read lat and long as floating points, right? Not as strings or anything like that. Right? So let's see how many records it read. Right. So 1 second. Right. So I read, right, what 10,000 records, right, more or less, and this is how the records look like. So pickup time, lat long, base. Right. So this is a cleanup. I'm going to just drop all the null, all the null values. The data is pretty clean, right? We only drop 0 records. So, and here's the Spark. Basically, what I'm doing is I'm building a feature vector. So really, what I'm doing is, right? Since I only care about latitude and longitude, because I'm going to group by these two guys, lat and long. So that's my input to my algorithm, right? So what I'm doing is I'm sort of building a new feature column, just using these two guys, right? It's kind of hard to read because right, you can sort of see here. Right, it's kind of truncated, but all I'm doing is like I'm sort of I'm building a vector with just these two guys, because the vectors here, Spark needs vectors as input, not just individual numbers, or not individual columns. So that's why we are building a vector. All right. So I got the feature vector going. Yeah, just if I see a question, I'll come back to this one. Yeah, it's a good question. All right, guys. So here's what we are going to do for k-means. So I'm going to find just say 4 clusters. So as you can see, I'm initializing k-means, right? I'm saying, okay, right, number of clusters 4. Okay, and that's it. I say, okay, go and find me the clusters. So you can see it's busy. It says, oh, hey, just took 2 seconds. Came back and said, okay, yeah, right, I found 4 clusters. So 4, and it kind of says WSS. This think of like an error matrix. Remember when you do regression, you use the loss function or the error function. This is the same metric for k-means, right? So what you want to do is you want to sort of minimize the error, right? Now I just did 4. I don't know if 4 is going to give me the lowest error, right? So what are we doing is so we just simply do like a very quick hyperparameter tuning. I say, all right, you know what? Try k from 2 to 10. It's just a simple loop, right? Nothing, it's a simple for loop. And as you can within the for loop, I'm doing k-means, and I'm going to print out the results. That's it. All right. So let's get this going. So right, nothing fancy, right? I'm just doing a simple Python loop, and I'm submitting a Spark job, right? And you can see, right? So different values of k and different value of WSS. And as you can see, as you sort of increase number of k's, let me sort of plot this, it'll make sense. As I increase the number of k's, right, my error is coming down very rapidly. And this is a kind of a typical, k-means plot, if you remember this, right? And remember, if I keep increasing k, it'll just keep going down and down. But the big improvement is on the first few cycles, right? So if I ask you, okay, this is good. So what's a good k? Maybe like 6 or 7 would be a good k, because after it's kind of flattening out, right? And kind of bouncing around at the bottom. So let's say, again, that's why it's important to plot the graph so you can actually see it visually, right? So I'm going to say, okay, you know what? 6 seems to be a good number of grouping, so I'm going to choose 6, right? So I'm choosing number of clusters 6. Again, how did I choose this? by evaluating the graph and saying, I mean, if you would have chosen 7, right? Nobody could argue with you, right? And you don't want to choose too many clusters either, because then your interpreting kind of becomes harder. So it's a kind of a judgment call, right? So 6. So let me do 6 real quick. So again, I'm just doing k-means, right? So and prediction. So this is what happens actually. So I'm gonna print the results. Will make a little bit more sense. So it says, okay, I found 6 clusters. So the first column is a cluster number, right? Cluster number 0, 1, 2, 3, 5. 6 clusters, right? And then how many pickups were in each cluster? So the first, cluster number 0 had 4,000 or so pickups. Cluster number 1 had 493, and you can see the numbers are not equal, right? And that's fine, because not all clusters are going to have the same number of data. And it also prints out, okay, where the cluster is centered. Again, this is all fine. Like, I mean, I sort of look, I ran k-means, and I'm sort of predicting, 6 clusters. I found some data, but let's make it a little bit more interesting, right? Because remember, this is GPS data, so it's kind of, we don't need to sort of look at just numbers. We can actually plot this, right? So here's what I'm going to do. So this is I created this notebook on JS Fiddle as I was playing around. Let me see if it's still up. Okay, very good. Yeah, still up. Good. So I'm running a Spark code, right? What it's going to do, it's going to spit out, I'm going to do the exact same thing, right? I'm going to just basically, run k-means, but what I'm going to spit out is I'm going to spit out a JavaScript to visualize. So what I was thinking is, okay, how can I visualize this? Because as you can see, there are there are some clusters that are that are hot, right? Like cluster number 0 has 4,000 pickups. Cluster number 1 only has 400 pickups. So I was thinking, okay, how can I make sure, like how can I tell the significance? So one way you can think is imagine you're plotting on a map. I could use like a different pin color, right? Maybe like I can use like red color pin for this, to pinpoint the cluster. What I thought was I'll do, just something a little different. I'll say, I'll just do draw a circle, right? So the bigger the circle, more demand, right? So the reason it's overlapping is because, right? Because, I don't want to take circles too small, then it's kind of hard to see. So again, like I said, this is just visualizing, right? So the lights are kind of, centered around the center of the circle. The bigger the circle, more demand, right? So just to me, at least, it's easier to visualize than doing different color pins. All right, how do we make it happen? So I just execute this piece of code that spits out some JavaScript code, right? And I'm going to copy this whole JavaScript code right here. So if you're doing this, copy this, don't miss any brackets, right? Copy it here, go to JS Fiddle, right? You sort of paste here. Again, the instruction in the notebook. So paste the notebook, JavaScript, tidy up a little bit, and then run this. There we go. That's my new map. Pretty cool, huh? So remember, this is, Manhattan, right? So let's look at the data. So the one big giant circle, as you can see, is basically centered on Midtown Manhattan. No surprise there, right? Because that's where a lot of the Uber rides are being requested. Next biggest circle, right? This guy here, it's kind of, where is it? Like maybe Central Park around there. Yeah, again, makes sense, right? So when you see this data, right, you can instantly sort of see, right, what the demand looks like. And you can make it like a live dashboard, so during a period of time, the data can change, right? And then your plot can sort of reflect. So I really like this lab because just using just a few lines of k-means, you can kind of visualize something pretty cool like a Uber demand pickup, right? And this is part of a part of the lab we do in our machine learning class, and that's why I want to demo it to you guys, because this is one of my favorite labs. Right? All right, remember we had 6 clusters, right? Do we see six clusters here? Right, 1, 2, 3, Brooklyn, 4, right, 5, and 6, right? So there you go, right? So it segments the traffic in little clusters. Now, question for you, and I want you guys to think about this for a minute and type in your answers in the chat window. See these 2 airports here? This is JFK, right? And this is Newark Airport. shouldn't this airport have a lot of pickups, right? Because those are the busiest Uber pickup right spots, right? Why am I seeing like they're not as big as these guys? And to give you a hint, this data is from 2014. Can anybody think about this and say why I'm not seeing too many airport pickups here? Again, remember, this is the year 2014. The data is from 2014, right? Please go ahead and type in your chat window. I'd really like to see what you guys have answered for this. Again, the question is, why am I not seeing too many pickups at the airport, right? They, I mean, compared to Manhattan, they're kind of, they're kind of tiny, right? What do you guys think? Good, good. I have a couple of answers. Yeah, interesting. So yeah, you guys really kind of nailed it, I think. Yeah. So the answers are basically, so one answer is you're saying maybe the airport pickups. So there are a lot of airport pickups, but Midtown, there's so much demand in Midtown, like it kind of dwarfs everything else. Possible, right? Yeah, right. So maybe there are so many people in Midtown Manhattan, Midtown and sort of Central Park around area. Even if there are a lot of people coming to the airport, they are probably just dwarfs the demand, right? Probably, yeah, makes sense. Remember, this is 2014, right? And this is kind of when Uber kind of launched, I believe, and they were banned from a lot of airports. Remember this, right? A lot of airports actually banned Uber and Lyft from picking up passengers because they were like the taxi companies were they had a very strong lobbies, and they said no more Uber, right? And that didn't last long, right? It maybe last like a year or so, and then now now Uber and Lyft can pick up at any airport because they pretty much took over. But remember, this is 2014, right? Early days of Uber and Lyft, where they were kind of fighting with all these established interests. But pretty cool, right? So the reason I asked the question is, right, and this, I remember when you're doing machine learning, when your model kind of predicts something like this, you need to be able to defend this, right? Like, is this right? Like when you look at this model and say, okay, this is the demand map I'm seeing. Does it make sense? Why is there, right? So that's why I always tell my students, when you run your model, right, test the model, you should be able to defend your model. Yes, this is why I think it's doing this, right? So thanks for the answers, right? So yeah, so I had some pretty good, interesting answers. And another answer is basically, you said maybe a lot of people use public transit to go to the airport, right? Because New York has pretty decent public transit system, right? Yeah, that might be true, right? So rather than people taking a taxi or Uber, they may probably using a subway, right? So yeah, so that's possible too. But anyway, right? So the point is you should be able to sort of look at the model, what it's telling you, and be able to make sense of this. Anyway, pretty cool stuff, right? So again, you have the notebook. You can play around with this one. What else I want to highlight here? Any other question on this one, guys? Again, so the notebook has all the instruction, right? So again, I'm working through you guys on this one. It has all the links, everything, right? So question is, how do I run this notebook? Right? So I mean, because to run this notebook, you need to have Spark installed. The simplest thing to, I mean, if you already have Spark, you can run the notebook. You can download the notebook and run this. But probably the simplest option is, and that's what I'm doing. I'm actually running on my Docker container. So we are building a Docker container. Yeah, I'll put this link. So you can actually grab our Docker container, and it already has all of these things installed automatically, right? So let me put this link here at the end. All right, so you can just pull this and try this in. And if you have any issues, just shoot me an email. This is what we do for all our training, so we want to make sure this works for you guys out of the box, right? Yeah. So okay, so that is running through Jupyter. And as you can imagine, this is pretty cool because Jupyter, is great for experimenting. I can see plots, right? I can, right? And I just did with like a simple data set, 10,000. Okay. So what I have is, another file I uploaded. It's also, so this is the IPY notebook. This is a Jupyter notebook. You can run on, the Jupyter, great for experimenting. Then I also checked in a Python file, which you will see in the directory. Let me show you the Python file. So basically what I've done is once I've done experiment in Jupyter, I convert it into a Python file. And it's very easy, you go to Jupyter and you simply say file, export notebook as, sorry, not this one, you go to Jupyter and say export notebook as script, right? And it's going to give you, right, just simply say, and it's going to say, yeah, do you want this file? Sure, right? So it's going to download a Py file. So what Jupyter will do is it'll basically kind of strip out all the Jupyter stuff, related stuff, and give you a plain Python file. So that's what I have here, right? So as you can see, right? So what Jupyter does is it sort of comments out all the, all the Jupyter, like all the markdown stuff, just the plain code. So what I've done here, guys, is, right? So because I want to run this on a on full data set, right? So and again, this is the data set I downloaded. And so instead of running on a simple file, I'm going to run on full file. So if you look at the README file, you got the instructions. How do you run this, right? How to run the code, right? Jupyter Notebook we just went through. And if you want to run command line, this is the command. So basically, I'm just using Spark submit. And what I'm doing is I'm running on, let me bring the command up. I'll explain this command one by one. So I'm running on local mode, right? But the star basically results like, it's like a wildcard. I'm telling Spark, use all CPU cores in my machine, right? Because even when I'm running on local, I have a decently sized machine, right? It has, I have like, 8 CPUs, but, virtualized, like whatever, the hyper-threading, whatever. I have 16 cores, right? Which is pretty neat. And I say, just to use all cores, right? And I'm saying executor memory, just to, 12 gig memory, just use up to 12 gig because I think I have 32 gig memory, and then run the script, okay? So let me, again, remember, this is I'm running on my local machine, right? Because you kind of want to do this before you go, go to the cluster. All right, so it says, okay, I'm reading, whatever, 22 million records, right? And what it's doing is running, k-means on different Ks. Remember the hyperparameter tuning we did? Yes. So I'm just running on like, 2, 5, and 10. Okay. You can sort of see my CPU going crazy, right? You can sort of see this right here, right? This is before, and now you can sort of see here, right? All my CPUs are now redlining, right? so this will take some time, right? It'll take like a couple, 2 or 3 minutes for it to run through each K. So while it's doing this, I want to show you guys how to do this in Google Cloud, right? So remember, this is again single machine system, right? I have Spark locally installed, right? This is my Spark installation. Again, all the instruction guys, they are here. I can read through them, and I'm telling you how to run this. And you can see, right? It's really, it's really going real redlining my CPU. So now let's say how to run this in the cloud. So I'll let this run for a while. So for cloud, what we are going to do is we are going to look at Google Data Proc. So you just go to Google Cloud, right? Right. This is the one that gives you on-demand clusters, right? So you can sort of, and you can sort of see here, you can read about Data Proc, and you can tell, what they're doing. They're kind of giving basically, they're managing the entire cluster for you. Right? So let me show you guys the Google Cloud. There we go. Right, here's my Google Cloud account. So I'm in my Google console, and here's my Data Proc. Right. All right. I think I have a cluster. Here we go. I already have a cluster, and this is what I'm going to be using. I already have one spun up, and you can see it has three machines. Right. So, but let me walk you through a quick process of how you spin up. It's very easy. Simply go and say create cluster. Right. So cluster name, where you want the cluster, location, And here's basically, you sort of say, how many master and how many machine workers you want. So I say, what, I say I want one master. For the master, you can choose, the spec, right? So they are recommending 4 CPUs and 15 gig by default. That's sort of the minimum. And you can sort of go as much, you can go crazy, right? You can go like 32 CPUs, 120 gig memory, right? Or you can use even high memory instances, right? Has like almost 512 gig memory. Anyway, right? At this point, it's just how much money you want to spend on this kind of a question, right? And you select the disk size. And then for the workers, same thing, right? You choose the worker spec as well. Again, I'm going with the recommended standard for CPU and 15 gig, right? And you can select how many workers you want. Say here says 2. Let's say I want like 5 workers, right? And then you can also you want to enable this component gateway, right? Because this gives you like a nice UI for you to look at all your progress. And then in the advanced options, right, you can select what kind of you guys want. Like for example, if you go to the image, right, they're gonna give you like a more conservative image, 1.3, but you can choose like the latest one, 1.5, that has the latest Spark, right? So again, you have pretty good, plenty of choices here, but Spark is like just 2.3, 2.4. So I'm comfortable in Ubuntu, so I'm choosing the latest Ubuntu image, right? And select. And that's it basically. Just then and another cool thing is like you can check this. You can say delete this cluster if I don't use it for like 2 hours. And I highly recommend you guys do this because if you leave this running, this will really put a dent in your credit card, right? Because these are multiple machines running, and trust me, I've done this. I spin up a cluster. I say, okay, I go for dinner, and then I completely forget about this, and then I realize after 2 weeks, oops, I left a cluster running, right? So lesson learned. So now when I do this, I always kind of say, okay, hey, delete the cluster after it's idle. So highly recommend it. Anyway, so it'll monitor the cluster and it'll automatically shut down the cluster if no work is being submitted. And that's it, right? Then hit create. That's it. So right. So as you can see, it's all UI driven. Just a few buttons here and there. Just choose your cluster size, your machine spec, right? What do you need? And then select some, make sure the UI is enabled. And that's pretty much it, right? So I'll cancel out of this because I already have a cluster running. So I'll kind of cancel out of this and let me use the one I already have. So we just click on this one, right in the cluster. You can sort of see here, right? I have a 4-node cluster, 1 master, and 3 workers, right? And here are my web interfaces. And again, if you're coming from a sort of a Spark, Hadoop world, you'll instantly recognize these. This is Yarn. Yarn is manages the cluster. So go ahead and click on this guy, right? So this is going to show you what are the process running, right? And so let me bring up Spark as well, right? So kind of, right? Again, and this is why it's important. You want to enable the UI so you can sort of, have access to all the UIs. Without them, you wouldn't be able to see these. All right. So as you can see, you can see I was going to experiment with this a little bit, right, just to make sure things are working, right? And so let's actually see if we can run a job, right? So usually what I do, I just directly log in to one of the VMs, and the best thing to do is like I just log into the master. You simply click on the SSH window right here, and they will automatically spin up a window and connect you. If you ask me, this is my best feature I like in Google Cloud, right? And if you sort of suffered through SSH private keys, public keys, and all the nonsense, you will really appreciate how easy this is. Like one-click access, right? So anyway, so to me, like it instantly tells me whoever sort of designed this has really thought through how people want to access their clusters, right? So just a single access everything through. There's no need to sort of configure keys and any none of the nonsense. Just simply click and connect it, right? All right. So here's my window, right? And let me see how I'm going to submit this cluster here. All right, so again, instructions on the cloud. So can I walk you through the steps, right? So here's I already have the file uploaded. So here I'm showing you guys how to upload the file, right? So let me actually look at my k-means. So same file, right? Exact same file. The only change I had to do I changed the data location to like Google storage, right? Just so you know, so we can pull the data from Google storage. And this is a public bucket you can see here, and you can use this bucket too. It'll actually pull data from our bucket. All right, so that's all set up. So all I'm going to do is simply, right, that's just that, right? So Spark submit, but this time I'm saying master yarn. Why? Because I don't want to run locally. I want to run on all the VMs I have, right? So the default cluster manager they are spinning up is yarn. You can sort of see here yarn, right? So I'm going to say, hey, use yarn to run my job. That's it. So that's why I'm saying Spark yarn, right? And that's it. And the file name. And then I'm sort of timing it just so I'm curious, how long this is going to take. That's pretty much, and I'm sort of saving all the logs. So let's hit run. So the top window, remember this top window is Google Cloud. The bottom window is my own machine, right? So my own machine is still going on, right? So it's running it's going through 3 Ks, right? You can sort of see here. So, right? So when K equal to, that it took like, 108 seconds, then, 180 seconds, and then, 150 seconds. So what you'll find is, and this is kind of a true, like as you do more and more Ks, your time will keep going up. So to me, as you can see, each loop is taking about 2 to 3 minutes, right? So it's done with all 3 Ks, and now sort of doing like a final round, right? And you can sort of see here, right? My CPU has been really right, going bananas, right? So okay, and so okay, so mine's still running. So here's my Google, starting up, right? And again, same thing, exact same code, right? It's going to run through multiple Ks, yeah, right? And then you can look at the monitoring, and this takes a while to kind of refresh. You sort of see here, right? So far the CPU has been, idle. You'll see it's going to pretty soon it's going to spike up, because this like lags like a few seconds, and then also memory. You sort of see it's kind of going up, right? Anyway, so you sort of see your job is kind of running on all the machines on the cluster. Okay, so it's just spinning up. All right, let me see, is mine done? No, it's still going on. All right, guys, so as this is going on, I'm gonna stop here for a second, and let's have any questions, right? Because this will take a few minutes. So let's kind of make use of the time and answer any questions you guys might have. And if you reload this, you guys will see, there we go. See, here's my latest Spark job. So sort of the one I'm highlighting, see is running, right? And right, you can sort of see how much memory and right, how many containers running on, how much memory is using, the whole deal, right? So this is the this is just a traditional yarn UI. You'll see it's kind of a it's not a fancy UI. It looks like a website from like 1990s, right? But but they kind of publish all the information, right? So so this is my latest job. Latest job shows up on the top, and you can see it's a Spark application. K means Uber, and it's running right now. So it'll take a few minutes to complete, right? All right, guys, let's get some questions going. Right, so one of the questions was the notebook needs Spark. Yes, right. So here's the thing. I don't think Google Colab has Spark installed. So I'm not saying you cannot do it. It's not installed by default. So what you want to do is like, you kind of want to spin up your best bet is like doing like a data proc, like I did in Google, that actually has Spark installed, right? So if you go to the clusters, right, you spin up a cluster. You can just do like a single node cluster if you want, right? And that'll actually have Spark installed. So here, remember I chose 3 machines as a worker node, you can just do 1. Right? So that's the most effective way. But installing Spark locally is, is very, very straightforward. I'll add some instructions here, guys. But the best thing you can do is like, get our Docker file, Docker container that has everything installed. Yeah. So, good. So that's that. Any other question, guys? Please keep them coming here, because like I said, we are waiting for the, these guys. And you can sort of see here, right? It's gonna make some headway, right? So, I think you will notice this. It's kind of subtle. You really have to look for it. Look at these two, right? Look at these 2 times. So here's my, remember this is my local machine, right? You can see as the K increases, the runtime also kind of increases, right? So I started with 108 seconds, and this is milliseconds, so just look at 108 seconds, 187 seconds, and so on and so forth. So as K increases, my runtime increases. But here, look at this one, right? Starting at 54 seconds for the first loop, right? So that's already like, half of what I'm doing here. And the other one is, yes, the time kind of goes up, but not like, not like by, almost 2x, like here, right? It's kind of just goes up slightly. And this is the beauty of cloud, because why? We have pretty much linear scale. So we are running a lot of machines, and there we go. So, so even look at this one. So even the K10, it didn't go up by much, right? Just slight increase, right? And this is the beauty of cloud, because you have scale, and then Spark's algorithm scale regionally up. And here's the final run that's done, right? So it's kind of going on. So my local one is done, and you can sort of see, right? My GPUs are kind of taking a break now, right? But yeah, right. So basically, what it does, like, it's giving me the same JavaScript that I can use to plot my data, right? So overall, it took like about 12 minutes on my machine, right, running a single node. So the cloud should be maybe half that, I'm guessing now. All right, guys, so, right, again, like I said, we go to the cluster, we do the monitoring, right? So you can sort of see here, right? So okay, there you go, right? See the blue line kind of spiking up, right? So that's my, right? That's my process spiking up, memory going up. Let's see how CPU, there we go, CPU spiking up, right? So my job is kind of kicking up right now, right? So my job is currently executing. So that's pretty neat, right? And this is the overall cluster. It's running on multiple machines. Let me see. Yeah, I'm going to wait for this to complete. So while this is doing, I want to show you guys one more thing. There we go. It's almost done, right? There we go, right? So K-means done. You can look at the Spark UI, right? So these are my previous applications I ran, just before the class. So you can sort of see here, right? These apps are like named, like job 1, job 2, job 3, right? And if you look at it, look at this detail. Let me show you a few things. Right. So click on this one. This way, it's important to enable the UI. You can see here, right? It's been pretty busy, right? So you can look at this. So let's say it's something that took some time. Let's say this guy, right? So it's doing. So K means like we're doing some sort of a summing, right? So we click on this, and I'm gonna keep drilling down on this one. There we go. This is what I want to show you guys. All right. So take a look at this one, right? See, these are all the executors. Look at these machine IDs. This is worker 1, worker 0, worker 2. Remember, we have 3 machines, remember? So you can see Spark is basically distributing the work across three workers, like worker 0, worker 1, and worker 2. Pretty cool, right? And each machine you can sort of see more or less, 25, 30 seconds is kind of what they're working on, right? And you can also see things like how much data they processed. So all that. So even though it's a UI is kind of pretty basic UI, it publishes a lot of useful information. And also, if you look at the task level breakdown, same thing, right? You sort of see here, right? Running on multiple machines. So this is how we verify, yes, my job is indeed running in parallel, right? Not just running on a single machine or a single notebook. Spark is distributing my work across multiple workers. Pretty neat, right? So, and then let's see what else I want to show you guys. Oh yeah, timeline. So we can click on the timeline. All right, this is pretty neat. So you guys can see here, right? This is a machine, like machine worker 1, worker 0, right? And you can see the green one is like the execution time. And you can see they're all executing in parallel, right? So this is worker 2 machine, worker 1, right? You can sort of see here, right? They're not waiting on each other. They're kind of executing all their jobs in parallel. And you can sort of see here, right? See that this is a legend. You can see here, the green is actual computing. And as you can see, computing is in parallel, right? And some of the compute, you can see it has to wait for the others to finish, right? Because there's a sequence, right? Because imagine, I'm the final guy who's adding up all the numbers. right? I had to wait for everybody else to finish, right? So things like that. So you're gonna see like it's like almost like the project chart. You will see like a Microsoft project, right? Same thing. But you can see most of the machines, all 3 machines here, are executing in parallel. This is the beauty of Spark, right? So let me see, this should be done by now. There you go, it's done. So right, so it took about 6 minutes, right? 12 minutes to estimating. And if you're wondering, okay, that's just 6 minutes. Remember, I just chose like a very small machines, right? My Spark machines are my cluster. If you look at the cluster spec, right? I just went with like a the smallest thing you can possibly do, right? If and I only have 3 machines. So if you did like we did like more like maybe like more machines with a little high power machines, you will see this will like really zip through this. But at the end of the day, right? You may have gone through a lot of data, but at the end of the day, it just produced, right? Basically, the final JavaScript I'm looking for. Right? This is what I'm looking for, right? This is my final JavaScript. So right? Let's say I want to sort of plot this. Let me see if I can do this. Should work. So here's my final JavaScript, and if I go to my fiddle, there you go. All right. And remember, this is like running on all. So hopefully, I think this will work. I hope I copied everything. Run it again. There we go. Right. Here's a new map, but this time with all the data, right? Not just one file, right? But more data, right? So yeah, so and then it's more of the same thing. I think you see like a little dot here, like a little red dot here, right? So yeah, so pretty neat, right? So very easy. So imagine the scenario, right? This may have gone through like I don't know 10 terabytes of data. Maybe it took like 2 hours, but at the end of the day, right? What this is the final outcome, right? Just giving you a nice JavaScript that you can visualize the data. Right? So that's it. So that's right. So you can sort of see how easy it is, right? So the basic takeaway here, guys, today, right? So just to kind of recap, basically what we are doing is we went from Jupyter Notebook, right? We try, we try our application on like very simple small data. Once that is working, I showed you guys like a kind of a full Python script, but I'm running on my local machine. But typically you wouldn't be able to do this, typically because you just data just too much of data. But maybe like I sort of look at Jupyter as like a small, command line is more like medium, right? And when I go to the cluster, it's sort of the large. I think like t-shirt sizes, right? And then yeah, that's it. Spin up a machine, just log in and run your code. Nothing to install, nothing to set up. Yeah. So question is, how do I know I need to use k-means? Good question, right? Again, this is, so that's the sort of the machine learning, sort of the data science question, right? Do you want to use k-means? K-means is a great use case if you want to sort of cluster things, as in like, find patterns. I just use this example because, like I said, this is one of my favorite labs with a nice visualization. This could have been a simple classifier, right? Simple regression code, either way. And Spark, if you go to SparkML, right? Right? And if you go to, go to your docs, wherever docs, I think, yeah, always get this wrong. Oh, okay. All right, there we go. All right, so, and then you go to the programming guide and then look at the machine learning guide. They will walk you through, what they have, right? For example, how to do things like, regressions, pipeline, what are the algorithm they have, the whole thing, right? So there we go, classification regression, right? So they'll walk you through, what are the algorithms. So for example, here's how to use random forest, right? And they give you, the cool thing is they'll give you code in like all languages. Here's how we use random forest in Python, right? So yeah, so the document is pretty nice. And let's say you want to do like clustering, same thing, right? Go here. Let's say I want to use k-means, right? So this is what we used. So pretty neat, huh? So Spark has all these things built in, and the beauty of Spark is, right? You can start on your notebook in Jupyter Notebook and go from single machine like I did here, single machine to a cluster. Pretty much, straightforward. Like, without you don't even have to change any lines of code. All right, guys. So that's it, right? Basically, machine learning and Spark at scale. Any other questions? So logistic items, again, just so we are kind of coming close to the end of this. So again, please come to the main, right, main doc, look at the class folder, and under that, right, go to the section, session today, and then look at the README file. And then everything here, you can just download the whole directory, right? That's the PDF slides, Jupyter Notebook, and the Python file, right? That's it. I think we did a pretty good time. Any other questions, guys? Oh yeah, so question is comparing Amazon versus Google versus Azure, right? That's a good question. So okay, so I use Google Dataprog, right? Because I've been working on a project for lately, and I've been just using it, so I just use Google Dataprog, right? Amazon, same thing, right? If you go to Amazon, like if you go to Amazon EMR, right? Right. So they have the same deal, right? So you just spin up a cluster, right? Do your work, just log in and run your apps, and then shut it down. That's it, right? So even though it's called Elastic MapReduce, right? It's it actually does support Spark. Like I said, we don't do MapReduce anymore, right? So all these actually are available. Azure, same thing, right? Azure, they are pretty much the same mechanism for you to spin up. Yep. Because and another thing I sort of like this, and I remember Mike was showing you guys the last few sessions how to natively do SageMaker. I sort of like Spark. Here's why: because if I'm writing on Spark, I don't have any vendor lock-in, right? Because I can take my Spark code and I can go to Amazon, I can go to Google, I can go to Microsoft, right? I'm not bound to a particular vendor because my only dependency is Spark. And as you can see, Spark is pretty powerful. It has all this cool stuff already defined, and it gives me cloud portability, right? And and because one of the big selling points of cloud vendors, like come here, we'll give you scale. But like I say, seeing here, Spark gives me scale. So sort of the way I'm sort of thinking is like this, right? Let me see if I can do a quick annotation, right? So think of like my basic cloud vendor, right? So and then I'm Spark on top of this, right? And I'm here, right? So my dependency is on Spark. So this kind of gives me a pretty neat way. So I'm developing on a very nice framework that allows me to go for develop on my laptop and go to cluster very quickly. And at the same time, I don't have a lock-in, right? I'm not using like a native cloud API. The reason I mentioned this is for a couple of our clients, this was very important. They did not want to get into cloud native APIs because they didn't want cloud lock-in, so they preferred Spark. So yeah, right. So again, there's a case made for either way, right? So if you want cloud neutral, Spark is great. But if you're okay with going with the cloud vendor and using their own APIs, that's great too, right? So again, there are choices. Good, guys. What else? Let me go through the Q&A very quickly. Look at the chat window too. Oh, by the way, yeah. So Google also gives you free. If you sign up for Google, you also get free time, right? That's what I'm trying to say. Yeah, because I think the same thing. They do like a Microsoft. They do give like a 1 year, right? 1 year free or something like that. Yeah, so you can check it out. Go. Databricks and Spark. What's the difference? Good question. Databricks, kind of the way I'll explain Databricks like this. They cannot do Spark. Let me kind of do the annotation again one more time. So they release Spark as open source. So this is the Spark, OS, right? Open source Spark. What Databricks does is they take this and then they add their own like bells and whistles, and they do their sort of a Databricks Spark, right? So it may have like a better integration with like some UI tools, right? It can, they actually give you cloud. They may have like a GPU support, right? First. So yeah, so it's kind of built on OS, gives you a little extra. The extras are usually on the sort of the productivity side, like nice UIs, dashboards, that kind of stuff, right? That's fine. And also, you can, if you're using the cloud, Databricks Cloud, you are using Spark, the latest Spark, without having to do any setup. And it's a pretty well done platform, right? You should check it out definitely. If you're doing Spark, I would definitely get an account on the community edition and kind of try it out. It's a very nice platform. Yeah. So I mean, so it's a kind of a freemium model, right? Just like all the open source companies are doing, like Cloudera and everybody else. Like, yeah, the base layer is free, so I know it's open source, and then they have their free, premium features, and then you sort of pay a licensing or something. Yeah. Yeah. So again, I'm sure they do a lot more than that. So I'm probably not doing justice for Databricks, but yeah. A lot of our clients, they use open source clients, but they use Databricks for support, right? So you can buy support from them as well. Yeah. So even if you're not using their hosted version, you can still engage them, providing support for you, right? Because they are sort of the authority for Spark. So, yeah. Good. Yeah. Great questions, guys. Anything else? Maybe one more minute, and then we'll wrap it up. And as usual, guys, I will send an email. And by the way, I want to kind of bring this up real quick. So I don't know if any of you are working, any of you know anybody who's working on COVID related projects. So we actually are trying to help out as well. So we're actually providing free training if you're doing, like, if you're nonprofit working on COVID, right? So I'll put this link here. So if you know anybody who is, please connect us, right? So the link is right here, right? Yeah, so we are sort of trying to contribute a little bit as well, right? So if you are doing some COVID-19 research, please reach out to me. Yeah. All right, guys, that's it. We have 5 minutes to spare. If there's no other questions, we'll wrap it up. And again, the lookout for the email. I'll send out the try recording. Okay. Thanks, guys. Thank you so much. We'll see you in the next session. Yeah.